Hello guys, welcome back to DevOps Doc. So today we'll do one project which is an e-commerce application, and the name of the application is Easy Shop. So this is an e-commerce application. Developing of this project goes to Train with Subham. So I'll give the credit to them. Actually this is a part of their hackathon project, but I'll be deploying it in a different way. Like I'll be using completely AWS. If you want to check the original repository, I'll paste that in uh, the description. You can check that. So we'll be deploying this thing in a different manner and completely different tech stacks and different tools and all. So I have one architecture diagram so that I can explain you in a better way. So basically this is the architecture diagram. So these tools and tech stacks we'll be using throughout the projects. Here is the user, and the user makes a request to the website, which is easysoft.devopsdoc.site, the website, and that will go to application load balancer, and through the ingress we'll be using EKS, and inside EKS through the ingress only we will be routing to the application and the monitoring. So we'll be using Prometheus, Alertmanager, Grafana for the monitoring. We'll use ArgoCD for continuous deployment, and we'll be using ELK stacks for logging. And if I talk about the CI server, we will be using Jenkins CI server, and the whole EKS cluster your will be in your private subnet. So and the private the EKS cluster is private access and private access point enabled, so that no one can access the cluster from outside. We'll be accessing the cluster from the bastion host itself, from the public subnet. The DevOps engineer here, the DevOps engineer resides, who will create all the infra using Terraform, so that we will maintain the infra as code, and to manage the EKS cluster we'll be using bastion host from public subnet. And once our deployment is done, we'll be exposing our application in Route 53, and my domain register is different. I like, if you want to know how I transfer my domain from Hostinger to Route 53, I have one tutorial for that as well. I'll put that link in the description. Please go and check it out. So here we'll be exposing through ingress through our ALB load balancer. So our application will be exposing as egsoft.devopsdoc.site, and so for Prometheus we'll be exposing prometheus-egshop.devopsdoc.site. I'll just copy and show you. Already I have deployed it. I'll just show you for demonstration purpose. Sorry, the uh, name is this one. Here is a typo. I have mentioned wrong here. It is prometheus.devopsdoc.site. Yeah. So here is my Prometheus, and here I have the log exposed. I can check the logs in Elastic, like in Kibana, and I have ArgoCD as well. And for monitoring purpose, I have Grafana. Yeah, I have Grafana for observability, and we have exposed the Alertmanager as well. So these things all will be exposing, and will be doing the projects. This is the repository. I'll put the repository link in the description below. And after once everything is done, this will be accessible by developers and QA engineers, so that they can monitor the application, they can check the logs, they can check the alerts. So once everything is done, then we'll be setting up the alerting. So we'll be configuring alert manager with Slack. So if anything goes wrong, then the developers and the DevOps engineer or whoever wants to get the notification, they will get the notification from in the Slack channel, like how I have here configured. You can see the firing alerts and all. So this will be the whole project. I'll be going one by one. We'll see everything in details, how we'll deploy, how we'll configure, and throughout everything I'll not be doing any single YAML file kubectl apply -f and deploying a single YAML file. I'll not be doing that throughout the session. Whatever I will be doing, that will be done by Helm. So we'll be using Helm chart. So this is the whole tech stacks, and this all thing we'll be doing today in this project. So without further any delay, let's get started. Let me quickly explain you the Terraform files. So first, I have the provider block. So here is the provider block, and the region I have configured as the local region, which is this one. And after that, Terraform state backend. And for the backend, I'm using S3. As S3 has a new feature which is lock file. Like previously for state locking we are using DynamoDB, but now S3 has a new feature which is use log file. Then I'll start with VPC. So here I have the VPC. I'm using VPC module. You can just Google it and find the module. Just you have to use this one, and this is the source. So this is the simple VPC setup. I have only single NAT gateway and disabled one NAT gateway per AZ to reduce the cost. And going further, for the variables I have a separate variables.tf file. Then I'll move to Bastion host. So this will be the Bastion host. From this host itself we'll connect to our EKS cluster. Alright, because our EKS cluster is a private cluster and private endpoint enabled, and all the nodes including the control plane resides in the private subnet. So to connect to the EKS cluster which resides in private subnet, we'll be needing an Bastion host. So this is the code for the Bastion host. And to install the tools, like in the Bastion host we'll be using Helm, kubectl, right, and EKSCTL. So this is the user data for the Bastion host. Then for the CI server we have Jenkins. Like for the CI server we will use Jenkins. So this is the CI server. You can see this is the ingress rules and all. So and this is the user data for the CI server. So I have Jenkins, then Docker installed. Okay, so now I'll go to EKS is the main part. So this is the EKS. I'm using EKS module which already available in Terraform documentation. You can just Google it, so you'll get it. And the endpoint public access, I have removed the public access and enabled the private access, so that the EKS cluster is only accessible from the VPC, right? And here's the security group rules. This is the additional security group, uh, so that our Bastion host can connect to the control plane, I mean the EKC cluster, right? So this is the additional security group for that. And these are the add-ons. I have added the add-ons like core DNS, kubeproxy, VPC CNI, and yeah, VPC ID will dynamically assign here from the module itself. And subnet, this is the subnet for the node group. So node group also, the nodes also will reside in private subnet and the control plane as well. Okay, and this is the manage node group. So I'm using T3 large, and I'll be using 3 nodes, and I'll use spot instances. You can take on-demand instance as well, that's up to you. And I have enabled remote access, so if anything goes wrong I can just SSH into that particular node and debug the things. Okay, So yeah, these all are the things in EKS. And yeah, one more thing, the access entry also I have configured. Like for this user, for the Terraform user, I'll give Amazon EKS admin cluster admin policy, and in this Bastion host I'll be doing AWS configure as this user, so that this user can access to our EKS cluster. So this is the access entry. You can use config map as well. This is the API access. You can use config map as well. Okay. So what else is pending? Yeah, output also, if you want to see see some outputs um, in the CLI, you can configure here as well. And yeah, with that being said, all the things in Terraform file has covered. And one more thing, the Terra key, like for this Bastion host and for this EC2, the key which is I'm using, I did SSH keys in my local machine. Then whatever key has generated, I'll just copy the public key to this Bastion host and the Jenkins server, so that I'll have the private key and the public key will transfer to uh, this host, these hosts, right? So that we can SSH. You can check here. Yeah, if you check the key pair, here is the key name and here is the public key file, which is this one. So now we'll go and do a Terraform plan. I already did the AWS configure. So before doing Terraform plan, you have to do AWS configure and give your access key and secret access key which you have generated in the user like which you have generated inside your IAM user. All right, and do AWS configure and set your keys and all. I have already have set, you can see here, so I'm just ignoring this part. I'll directly do Terraform plan. Yeah, so it will add 65 resources. I'll just go ahead and apply it. You just cross check whether all the resources you have here, those will create or not. Okay, just type yes to perform the action and approve it. It will take some time to create all the resources. It has to create VPC, EKS, all the things, right? So it will take some time to provision the things. As you can see, all the resources has been created. We have 65 resource added. Let's go and check in the console. You can see we have all the instances and the cluster is also ready and the VPC is also created. Yeah, great. So now we'll go to the architecture diagram. Here the first thing is so this is the GitHub repository. I have explained all the things here. Terraform installation done, install AWS CLI, that is also we did in our local machine. These things are done. You can refer to this documentation anyway. I'll directly go to Jenkins Setup. Okay, or you can do this one as well, I mean on the Bastion host. So for now I'll just directly go to Jenkins Setup, just copy the code. I'll check whether the Jenkins server, I'll connect from the browser itself. As part of the Terraform, we already have installed Jenkins in this server. We'll just directly check the Jenkins. Yeah, it's active and running. Let me copy the public IP and access it. By the way, this is the Elastic IP. The reason I have configured this as Elastic IP because we'll do continuous integration, right? And we'll be using Git webhook. So we'll configure this IP inside our GitHub. So anything changes in our Git repository, automatically the CI process will start, right? So if the Jenkins server restart, or sometimes you will stop it or and start it again or restart, so the IP will get changed and we have to again go back to GitHub and change the IP. So to get rid of that, I am using Elastic IP. Yeah, we can access the Jenkins UI. Let me grab the password. Install the suggested plugins. It will take a bit of time to install the plugins. Yes, all the plugins has installed. Let me give a random username and password. Save and continue. Jenkins, this is the Jenkins URL. Save and finish and start using Jenkins. Now go back to the GitHub repository and follow the steps. These are done. Install the essential plugins, which is Docker pipeline and pipeline view. If you not install this pipeline view, that is also fine, but Docker pipeline you should install it. Let me go to manage Jenkins. Go to plugins, available plugins. Choose Docker pipeline, then install. Go to available plugins again, search for pipeline. You can choose pipeline stage view and install it. Alright, it has installed. Then go to GitHub credential and provide your username password. Okay. Go to manage Jenkins again. Go to credentials. Click on global. Add credential. Username and password. Give your username here. I will give my username. And password, you can generate one token. Go to setting. Go to developer setting, go to personal access token, fine grained tokens, then generate a new token, give your password, give a token name, click on all repository and repository permission, actions read and write, administration read and write. So give these permissions. So I'll be using this token somewhere else, so that's why I'm giving these access as well. Alright, these are the repository permission, give the account permission, cool. Then generate a new token, then generate, copy the token and save it somewhere. Now go back to your Jenkins and give the password here, and the ID name you can give GitHub credentials. You can give any name, that's up to you. Then create. Following the same method, we'll create one username password for Docker. Let me go to my Docker hub. Log into your Docker hub. You can give this password over there, or you can give any access token. So for the safety reason, I'll give an access token. Go to your profile, my bad, go to account setting and go to personal access token. I'll generate a new token, access token, expiry, I'll just keep 30 days, and I'll give the permission read, write and delete. I'll give a name, then generate. Copy the token and save it somewhere. Now copy the token, go to Jenkins and set the password and copy your username, set it as username, and give the ID Docker or credential. You can give any name. This is kind of a identifier kind of a thing. It's not a good practice to show the tokens and all, but to elaborate the things, I'm just showing you this. I'll just delete once the recording is done. I'll just delete this one. Create. Yeah, let's go to the next step. Go to Jenkins shared library setup, configure trusted pipeline library, so that this repository will trusted by the pipeline. So you need to set up this one. Okay, go to Jenkins, manage Jenkins, configure system. Go to manage Jenkins, systems. So it's a huge list. Let me go and find this keyword, trusted pipeline. Add a new shared library. Just click on add. Give the name it shared. Then default version is main. Your project repository URL. Copy this one, paste it somewhere, and change your username. This is your project URL. Don't forget to change your username over here. Then this Jenkins shared libraries. Credential, just choose your GitHub credential and then save and apply. Alright, now get back to here. Go and create a new pipeline, new item, name that EG shop. This is a pipeline item. Click OK. Give a short description and go to your pipeline script from the source code management tool, git. Then give your repository URL. Copy. Credential, just choose your GitHub credential. For now I'm ignoring this git SCM polling. We'll configure this later on. And we have chosen this one. Let me cross check the Jenkins file. Yeah, it's already selected the Jenkins file. Now apply and save. And before build it in your Jenkins file, make sure that you have changed that Docker username and all. So see, this is the username. This is my username. So you have to change the username here. of yours. Okay, wherever you find that, you can change that. Okay, just change and save it, then configure there, like add the Jenkins file there. Now I'll just go and click build now. It has failed. Let's check why it has failed. Okay, it didn't find the repository. Let me go and check my repository. Okay, I don't have the repository. Let me fork it out. I think it's already mentioned here. In general, yes, it is mentioned here for the shared library repo, which is vars. Then after that, you have to update the Docker Hub username. Let me go to the original repository and get this one. Okay, this is the repository, Jenkins shared library from Subham Londe. You can fork it, or you can fork that from my repository. I'll fork it now. I'll keep the name intact. Yeah, alright. Now we have Jenkins shared library. Then yeah, inside the vats and inside that okay, it has manifest groovy. Yeah, we have to update our username, right? So here we have to update. Let me just quickly update it. Click on the pencil icon, then update this. Yeah, like this you can update and commit it. Now we'll get back to our Jenkins and build it again. Go to console output and check. So the reason we use shared library to, like, these are the files used by multiple application. So we'll create a shared library to reduce the number of duplicate library files on our system. So using this shared library only, we can create multiple projects or multiple pipelines. So that is the reason we have the shared library. We don't have to mention the Jenkins file and all. I mean, not Jenkins file, not library files. So for that reason, we are using this shared library. It is taking a bit of time. Let's wait. Now you can see the pipeline has succeeded. Yeah, now we'll do the CD steps, which is the main part. So CI part is a bit easy. You just need to provide the credential, just replace the Jenkins Docker username and use the shared library and run the pipeline. The main thing is the CD part. CD part will be completely doing in AWS. Let's SSH into our Bastion server. Let's go to instances, Bastion host. I'll connect that from the browser itself. Do AWS configure. Let it be connected. Yeah. Give your access key. Remember, we were using the username is Terraform, if you remember, and we gave the access entry to our EKS from that user only. So you have to give the access key and secret access key for that user to get inside your EKS cluster. Let me get the access key. Again, it's not a good practice to reveal your access and secret access key, but anyway, this is for demonstration purpose. I'll delete the user once the recording is done. Yeah, now we'll update the kube-config. Rename the cluster as our cluster name is doc EKS cluster. Just copy. I can rename it here. Doc EKS cluster. Yeah, and the region is AP South 1. Change the region. Yeah, the context has been added, and here is the path where the kube-config file is stored. Now if I do kubectl get nodes, I should say the nodes. Yes, these nodes are available. So the next step is to install the application load balancer. I mean the load balancer controller. To install that, I will use I'll refer this documentation. So now these are the prerequisites, which is a EKS cluster, then Helm, then these plugins are already installed. Let me show you. When we configured our EKS, then only we configured in the Terraform script to install those plugins, and those are running inside Kube system namespace. Yeah, this is the VPC CNI, then core DNS, then Kube proxy. Then this is the information about load balancing, service and ingress. So the consideration is IAM policy role, and if you have the role, then you can go to the next step. Okay, OIDC provider also, that was the part of the Terraform part. We already have the OIDC provider. I'll just go to identity provider and check whether the provider, yeah, you can see this is the provider we have. If I copy and go to cluster and just find, and yeah, you can see this is the provider for the EKS cluster. Yeah, so the consideration, like we have all the consideration whatever is mentioned here. Now we'll go and create the IAM role. First go to your server, then paste. We need to download the JSON document, like this is the policy document we have to download. Yeah, it's downloaded. Now we'll create the policy. The document has downloaded, but we have to create the policy inside our AWS account. It says it already exists. Let me copy and go to policies. So here is the policy that we already have. I'll do one thing. I'll just delete this one and create it again. So maybe previously I did, so that's why it already saved. So deleted. Now I'll create it again. Yeah, now you can see it has created. And then we need to create the role. This is the service account, and we will attach this one, this policy, to this service account. So the role will get created. Just copy and replace this cluster named and all. Region code AP South 1. Then this is the account ID. Copy the account ID, paste it. Then the cluster name. This is the cluster name. Hit enter. So you can see it's implementing a cloud formation to create the steps. Let me go to cloud formation to verify. You can see now only it has created. Yeah, created the service account, queue system. Inside the queue system namespace, and the name is AWS Load Balancer Controller. Just copy and do a get, so that you can verify whether like the service account is already available or not. Yes. Now what is the next step? The next step is installing the load balancer controller. Yeah, download the chart, then update it. And then install the load balancer controller. Add it to the notepad and change the stuff. I'll add this to get the unnecessary errors. But yeah, if you don't specify this one, then you have to go inside your EC2 machine and check the hop count of your IMDS. Okay, I'll just copy, paste it. The region code AP South 1 and the BPC ID. BPC ID is this one. Paste. Now copy the whole thing and install the load balancer controller. Yeah, the load balancer controller is installed. Now to check it, just copy the command and check whether it's running. There you can see there are two pods and both are running. So the load balancer controller we have installed successfully. Now what is the next step? We'll install the EBS-CSI driver. Let's do that as well by following this documentation. And before doing that, if you want to know more about the load balancer controller, you can go to the page, the GitHub page, and learn the things. Yeah, this is the documentation. Here you will find the documentation for the load balancer controller. Alright, now we'll install EBS-CSI driver. Copy the link and paste it here. So it's almost the same process. We'll follow EKS method. There are three methods you can do, like creating the IAM role, but I think this is the easiest one. Just copy. I have the notepad. I'll just rename those things here itself. Cluster name, cluster, everything else is same. Yeah, now copy the whole command and paste it to create the role. Oh, my bad. Actually, I did a typo here. It's DOCK. Let's check the CloudFormation. Say it's creating. See what is the next step. You can skip this step. Do not use KMS key. So we are not gonna use KMS key. So we'll just skip this step. This is the same step to create the role. Yeah, this is the step to get the Amazon EBS-CSI driver. Let me check the Helm. Yeah, this is the Helm repository. You can deploy a driver using customize Helm or manifest as well, but I prefer Helm. So I'll go with Helm. Copy. Now just upgrade it. Check if it is running. All of them are running. You can see the EBS-CSI driver, that is also installed properly. Now what's the next step? ArgoCD setup. To deploy the ArgoCD, we'll be creating one namespace named ArgoCD, and we'll be installing the ArgoCD inside this namespace. The namespace is created. Now to install ArgoCD, we'll be using Helm to install that. You can go to artifacthub.io, or you can click on the link. This is ArgoCD. Go to install. Add the repository first. And then install it. So we'll be installing in our ArgoCD namespace. Hit enter. Yeah, it is installed. So now to access the ArgoCD, either you can do pod forwarding, which we will not do. We'll expose everything via ingress. That's the reason we have installed load balancer controller. We'll be exposing everything through load balancer. So to expose that, we need to edit the values file, the Helm chat values file. I'll go to here and check the default values. So these are the default values. I have given you the values over here. So first thing first, you have to get the values. So this is the command helm show values argocd to get your values. Just copy the command and we'll store that in this file argocd-values.yaml. Now let me check. Yeah, the value file is here. Let's open it in BI editor. Alright. Now to expose this via ingress, you have to do you have to set up the ingress over here. Let me search for ingress here. Yeah, this is the thing, ArgoCD server ingress configuration. We'll enable this one. I have given you the setup. So this is the setup. So what we will do is just first enable the ingress. So before that, what I'll do is I'll just cross check whether the ArgoCD is running or not. Yeah, all of them are running. So I need to expose this server. Alright, open the ArgoCD file again, and this is the ArgoCD server ingress configuration. You can see. Now just enable this one. Then go to the configuration. Here I have given this is the global configuration config, then server ingress. So I didn't like write it from my mind. Okay, already it's already there. If you go to the page and if you go down, this is the ingress configuration, and yeah, this is what it is. AWS application load balancer in ingress configuration. So from here only I have copied. Alright, so I'll keep these things intact. I'll change the ingress class name. So the default class name is ALB. I'll change that to ALB. Config parameter, I have to make it server.insecure true. Let me find this out. Server.insecure. Make it true. And global domain, let's find this one. If it is pre-configured, let me check if it is pre-configured. Yeah, it's pre-configured already. This we have done. Now get the server and then ingress. Yeah, this is the server. Now go down to ingress part, which we were there already, but to make you find it out properly, that's why I was going one by one. The image section, extra containers, init containers, empty directory. Yeah, this is the ingress. We were setting it up right. This is the ingress. So in the ingress, the controller is generic. Controller you can choose AWS. So it's already here available. I have taken the code from here itself. Ingress class name we already have set it to ALB. Now the annotations. So the annotations I will copy from here itself. These all are commented out. You can ignore that. just paste it. So now here you have to change something. I'll explain you what all are these. So basically we are doing internet facing, we are creating internet facing load balancer. We don't want internal load balancer, right? Because we want to expose our application to the outer world. So that is internet facing. We are creating internet facing load balancer. We are telling our load balancer controller through this ingress that we want internet facing load balancer. Then for the SSL, HTTPS traffic, we will do SSL certificate. So that's the reason we have to provide the SSL certificate ARN, which we have created using SCM, AWS Certificate Manager. Then this is the group name. So this group name will combine all the ingress resources into one group, so that all the ingress resources will route through one load balancer. We won't create multiple load balancer. So this group name will help on that. And the target type is IP. So there are two target type, one is IP and one is instance. So now we are providing the route to our pods, right? So the traffic will directly go to the pods IP, not the instances. So that's why we have mentioned IP. And this is the backend protocol, which is HTTP, and this is the listen ports. So whatever traffic will come, it will listen on HTTP and HTTPS both. And one another thing is SSL redirect. So if the traffic comes in HTTP, it will automatically redirect to 443, which is HTTPS port. So this is all the annotations. If you want to add more annotations, if you have something, no, other criteria, so you just go to Google and type LB ingress annotations. You will have the list. Yeah, this is all the annotation you can take. So we are using this annotation, listen pods, and if I find group, yeah, group name. So these all are the annotation I am using that. Okay, all right. So now we have to replace our certificate ARN. So I already have the certificate created. If you if you are wondering how to create that, I just have a previous video on SSL and TLS certificate. You can check that out. I'll put that link in the description, or I'll add that in the I button. You just find it out. Go and type SCM certificate manager. This is the certificate for my domain, which is this one, and just copy the ARN of the certificate, go there and paste it. Yeah, all are done. If anything pending, let me check. Yeah, you have to give the host name. So this is a subdomain, creating one subdomain for the ArgoCD. And what else is there? Service type cluster IP, and the backend protocol version is gRPC. Let me search the keyword. Yeah, it's set to node port. We'll just set to cluster IP. And the backend protocol is gRPC, which is correctly already set here. Alright, now we'll just save this one and exit, and we'll upgrade the Helm chart. To upgrade the Helm chart, just do Helm upgrade my ArgoCD, then your chart name, then the namespace, then the values file. This values file is this one, not my values. This is basically this one. I'll copy it till here. And my deployment name is my ArgoCD. So this is fine. Yeah, let's update it. Okay, it says 2366 line 2366. There is something missing. Let me cross check. 2366. Two, 366. Okay. Oh, all right. So the thing is, if you're providing the values, you have to remove this. So I'll just remove these things. Now it should work. Yeah, it's deployed. Let's go and check the ingress. Let's check the ingress whether we have set the ingress. No? I'll just set in one alias for the kubectl so that I don't have to type kubectl again and again. Okay, get ingress ArgoCD. Yeah, we already have an ingress created, and you see there is one load balancer created. Let's go and check in the UI if the load balancer is available. Yes, it's still on provisioning state. Let's wait for some time to be provision it properly. And you see, so the moment you provision that and the ingress resource, it will create target groups. And in the target groups, if you see, this is the listener. So it's listen on, if you remember, we have configured that it will listen on HTTP and HTTPS both. So it's listening on HTTP and HTTPS both. And in HTTPS, and we redirected the traffic, right? So and this is the certificate ARN we had provided, the certificate ARN, and this is the rule. If you go and see, it created the target group, multiple target group, and this is for the HTTP. Sorry, this is for the gRPC, and this is for the HTTP. So if I go to the target group, let's open the target group, and inside the target group you should see the pod IP. If you remember, we had mentioned that pod IP, like the instance type pod IP. There are IP and instance both, right? I forgot. One second. Yeah, target type, not instance type, target type. So the target type was IP, not instance. So that's why these are the IPs. If I check these, it should be the pod IP. Let's go and check. Yes, so this is the server and this is the IP. Let me copy this one and I'll go here and just control F and find. You see, this is the exact same IP which exact same IP of the server. Server means this server, and for this server only we exposed the ingress to the load balancer. Cool. Now let's go back and check whether the load balancer has provisioned properly. Yeah, it is provisioned. Now what I'll do is I'll just create one record in Route 53. So in Route 53, I already have a hosted zone. Again, if you are wondering how to create the hosted zone and how to transfer your domain from another domain registrar to Route 53, I already have covered that particular topic in my previous video. I'll put that link in the description. You just go and check it out. So I'll go to hosted zone, and this is the public hosted zone. Okay, I'll just create one record. The subdomain is ArgoCD. This is the host we had configured here, right? Yeah, the type is okay, a record. Just choose the load balancer, application and classic load balancer, then choose the region, or you can just copy the copy the DNS name and choose the CNAME and do that. But this is a way to do so. I'm doing. Yeah. Now just create the record, view status, and wait it to be in sync. Yeah. Now if I already have copied argocd.devops.site and I'll just hit enter. I should see the argocd page. Yes. So we can access our argocd from this domain. Give the username. The username is admin, and for the password, we have to get the password from this initial password you see, right? From when you install that through Helm, you will get the command kubectl-n argocd get secret. Or I have mentioned here, yeah, I have mentioned here also. You can copy it from here. So the initial password you will just copy and execute the command so that you will get the password. This is the password. Just copy the password, sign in. You can go to setting and change your password. Yeah, you can change your password update by clicking on update password. You can change the password, but I'll just for now I'll focus on deploying the application. So we already have the CI server ready. If you remember, we already have the CI part ready. So now we have ArgoCD deployed in our Kubernetes cluster. Now we'll deploy the now is the deployment part. The continuous integration is done. Now continuous deployment. Create a new app to deploy the app and go to the GitHub repository, and I have mentioned here how to deploy it. Give your application name. I'll name it as EasySwap. Project name, give it default. Then sync policy, choose automatic so that it will automatically sync from the GitHub repository. Source, you have to give your repository URL. Just copy. Yeah, the path. So here you have to provide the path where your Kubernetes manifest resides. Okay, so here if I go to my repository, I have all the Kubernetes manifest for the application inside this Kubernetes directory. Yeah, here is the application manifest files. So these are the manifest files. I'll just go to ingress and I'll cross check whether all the settings are correct. So you have to change in the repository so that it will the ArgoCD will pick the configuration files from the repository itself. So this is the ingress setting. I hope you already know what all are these, and this is the same ARN. I'll just cross check the ARN. Yeah, the ARN seems correct, and my host name is egsop.devops.site, which is fine. Yeah, all seems correct. Now I'll provide the name of the path. I mean the path where our manifest files are there. Paste the path name, cluster URL, just do https kubernetes default.svc, namespace, you can provide a namespace, let's say egsop. Yeah, now do create. Let me verify if I did all the things correct. Ingress annotations, route 50, yeah. After that we'll add the record to the route 53. Just click this one and you can see which all are already done. The MongoDB database parts are done. Ingress is also done. Still only the migration step is pending, and the pod is about to come up. Yeah, one pod is up and running. Yeah, all are synced and all the app is on healthy stage. Let's go to our cluster and check. We have the namespace as egsop, if you remember. Yeah, see, all the our application is running. Let's check the ingress. We have exposed our application through ingress, right? Yes. Now go to your load balancer again. You should see one extra rule. Yeah, you see, previously there are 3 rules. Now it has 4 rules, and you should see your application. Yeah, here egsop. So now what I'll do is I'll go back again to route 53, create one record for egsop, and this time I'll choose cname record, and I'll directly provide the DNS name of load balancer. This is the DNS name. Create records. Let's wait the status to be updated as in sync. Yeah, now let's check whether our application can be accessed from the public internet. Yes, we can access the application. So this is the application. For this application, the CI server is Jenkins and the CD is ArgoCD. So yeah, your application deployment is done. Let's wrap it up. No, wait for some time. We'll implement the monitoring and the logging setup and the alerting as well. Like how I showed you here, right? So if you now connect the dots, so basically we have set up this route 53 ALB, then ingress, then from the ingress load balancer controller, the traffic will go to EGSOP, then it will go to ArgoCD, then it will go to monitoring, then logging. So the EGSOP and the ArgoCD part is done. Now the logging and the monitoring we have to set it up. Then after this done, we'll be alerting through Alertmanager, and the alert fire will be happen in Slack, so that whoever will be available in that particular channel, they will get updated if anything down, anything like if anything wrong or right, that they will get updated in the Slack channel. And we are exposing one by one. You see, ArgoCD and the EGSOP we already have exposed. Now these things we will do. You guys are, I hope you guys are getting. And this is the bastionos through which we are managing the EKS. Now I think this will not look like challenging, because we almost done with 50 to 60%. All right, so now the application we can access. Now we'll implement the monitoring part, then after that we'll implement the logging part. So now we'll install the metric server. Again, through the Helm only I'll be deploying the metric server. You can just go to the link, or inside the artifact hub.io you can type metric server. Yeah, this is the one. Or you can just copy the link and go with the link, you will get the same thing, right? Take this, paste. That got crashed. Let me refresh it. I'll install it in the default namespace. Yes. The alias got removed. Let me reset the alias for the kubectl. Yeah, it's running now. Let me check whether it is working. I'll just simply do kubectl top nodes. It's showing the CPU usage and memory usage, right? So the reason I'm installing this one, I'll tell you later, because later on we'll be optimizing the things, like in how many nodes we'll be needing, or which pod is taking how many CPU and all. So for the optimization purpose, I'm installing the metric server. So yeah, metric server is done. Then yeah, top pods also you can execute and check kubectl top pods, and I'll check in EGSOP namespace, because our application is deployed inside EGSOP namespace. Yes, it's visible. Alright. Now we will do the monitoring part. So for the monitoring, we'll be using Prometheus as a time series database, and Alertmanager for alerting purpose, and we'll be using Prometheus rule, and alert using Alertmanager, and the notification will receive in Slack, or you can use PagerDuty also. If you want me to make a video on PagerDuty, I'll make that. Just let me know in the comment section. So for this video I'll be using Slack. For visualization we'll be using Grafana. Okay, so to do so we'll not be installing individual So there is a already, it's kind of an operator. If you install Kube-prometheus stack, all the tools using even node exporter also, if you use this Helm chart, then you will get all the things together and all will be managed and like integrated. Okay, you don't have to do, set up manually Prometheus, Grafana, Alertmanager. You don't have to set up manually. So I'll be using Kube-prometheus stack. Just copy and go to artifact hub.io, search Kube-prometheus stack and take the official one, which is this one. Alright, we'll go for install Helm chart. So before that I'll create one namespace for monitoring. kubectl create namespace monitoring. Now paste and mention the namespace. Sorry, for adding purpose we don't need namespace. To install we need namespace, because installation is namespace specific. It will take some time to install the things. Meanwhile, just go and read the docs. You can see install core components of Kube-prometheus stack, a collection of Kubernetes manifest, Grafana dashboard, Prometheus rule combined with documentation and scripts to provide easy to operate end-to-end Kubernetes cluster monitoring with Prometheus using Prometheus operator. As I said, it will install an operator. And this chart was formerly named as Prometheus operator chart, now renamed to Kube-prometheus stack. Okay, so yeah, and it has some inbuilt rules, Prometheus rules, so that you can see the Grafana dashboard, how many rules it has by default. I'll show you, and we'll access the Grafana dashboard as well. We will not create Grafana dashboard for Kubernetes components. So by default, whatever the rules will be there, that is enough for the Kubernetes components. What it says, maximum startup duration invalid value. Okay, let me do it again. Oh, okay, let's check the ports. Oh yeah, it's already running. Okay, ignore. If the applications are already running, then we can ignore this one. Yeah, you can see it's already running. All the things like your node exporter, then stack operator, Grafana, Prometheus, Kube state matrix, all are running. So now we'll modify to expose the expose Alertmanager, Prometheus and Grafana. So we'll modify that, and we'll modify for the Slack as well. Go back to the repository to take the reference. And yeah, one more thing, to modify that we will be needing values, right? So just fetch the values using this command and store it in a file. Yes, now view that file, and for Grafana we'll be using this Prometheus, this Alertmanager, this. Okay, all right, so we'll do one by one. Let's go to Grafana section. Yeah, let's go to the ingress part. So operator, here is the ingress. I'll simply enable it, and the ingress class name is already commented out. In ingress class name, I'll simply mention ALB. You know, right, how like why I'm in the ingress class name I am mentioning ALB, because I'll show you. Just 1 second. kubectl get ingress class. When I was installing a load balancer controller, then automatically one ingress class will be get generated from the load balancer controller, which is ALB. You see this one, right? ALB. If you have multiple ingress controller, then you can mention like whichever you wanted, you can mention that. Let's get back to our file. Yeah, ingress class name is ALB. Now annotations. I'll just copy the annotations. I hope you understand these all things which I already have discussed with you and already explained what each and every annotations mean. There is some extra spaces, just remove that. Yeah, what all are pending? Yeah, host. Just make the host as Grafana. Let's uncomment it first. Oh, okay, alright. I'll do one thing. Here only you have to mention. So remove the empty list. Alright. Now we'll move to Prometheus part. So in the same chat only we'll get Prometheus. Search for Prometheus. I just want to see the parent. Parent configuration. Or I will do one thing. I'll go to, it's a bit hard to find Prometheus. I'll go to the default values. This is the same value what we are seeing there, and I'll search Prometheus here, or ingress Prometheus. I'll just type ingress and Prometheus ingress. And what I'll do is I'll just find some unique keyword and search. I'll type this one. I'll find this keyword. I think this is the unique one, which will redirect us to this area. Yes, you can use this technique. So this is the Prometheus ingress. Make it true. Enable it. Then annotation. Copy the same annotation which I have given to you. then give the host name, then path. Okay, the path is commented out here. Let me check the indentation. Yeah, it's correct only. The path is commented out. Let's remove the list. Yeah, and what else is pending? Path. Yeah, path type also commented out. Just don't forget to mention the path type, otherwise it won't work. And make it to prefix. So the prefix means whatever after slash, whatever you will mention, that will like the web page for this one will come. And if you provide exact, that means only with this domain the app will be accessible. I mean the Prometheus app will be accessible. But implementation specific means that you are letting the ingress controller decide which path type it will choose, either prefix or either exact. So we'll just mention prefix because we want it in this way. Let's move forward to alert manager. Instead of finding this way, I'll go to here and I'll type alert manager enabled, and I'll do one thing, or I can just go to ingress, alert manager ingress directly. Yes, now I'll find one unique keyword and search. Let's say this one. This must be the unique through the whole file. Correct. Now add, first enable it, then add the annotations, copy the annotations from here, give the host name, remove the empty list, remove the default domain, I mean default host, paste your host, then paths as well, remove the empty list and uncomment it out. And path type, here it has mentioned the path type, make the path type as prefix. I hope you understand how each path types are different. Alright, our configuration is done. and alerting to Slack. Let's see first whether we will able to access these websites from outside or not. Then we'll do the alert thing. Let's save it and we'll do the upgrade. To upgrade, take this one, this command, and do the upgradation. Yeah, we have already upgraded. Now just check whether the pods are up. Yeah, those are up. Let's check the ingress resources. Get ingress. Okay, for the alert manager and Prometheus, we haven't set the class. That's why it didn't take. Let's set the class for them. Alert manager. Yeah, here it's commented out, right? I forgot to set it. If your application required to set the ingress class name, then you should set it. So previously for ArgoCD, I think it didn't require, so that's why it took the load balancer. But for this one, it has the requirement of setting the ingress class name, so that's why you have to set it. Now let's set it for the Prometheus as well. And upgrade the Helm chart again. Alright, let's check the ingress resources. Yeah, you see now all of them has picked the class and the address as well. Previously the address field was blank. Okay, now we'll go to our load balancer, and if you see listener and rules, now we should have more rules. I'll just refresh. Yeah, you can see Alertmanager, Grafana and Prometheus has added. Now go to Route 53 because we have to add that record to Route 53, right? Let's go to Route 53. Copy your DNS name, your load balancer DNS name. Create record. Then add the same as here. Alert manager. And choose the CNAME and paste your load balancer DNS. Alert manager spelling is correct. Create the record. view status. Meanwhile, I'll do the other things like Prometheus and Grafana. Switch to CNAME, paste that same load balancer, create the record, create one more for Grafana, switch it to CNAME record and paste your load balancer DNS name. Let's check the alert manager. Yes, we can see the alert manager is up. Like it was up there, but we can access the alert manager using this domain. This is called a FQDN, fully qualified domain name. Now let's go to Prometheus. Let's copy and try to access that as well. Same for Grafana. Let's go and copy the Grafana URL. I mean the domain. You can access. You can see Prometheus is up. Grafana is also up. Give the admin, give the username and password. So to get the initial password, what you will do is you can go to here and get Grafana admin user password by running this command. Or the initial password is from operator, but you can run this command to check. Yeah, you can see it's from operator. Copy it and log in. Yeah, so now if you remember, I told you that for this Kube-prometheus stack already we have some Prometheus rules for the Kubernetes components, and for that we'll be having Grafana dashboards, and I'll show you what all other rules are configured. I'll just open the file again. Let's go to the top. So yeah, you can see these are the default rules. Alertmanager, etcd, these all are the default rules. Kubelet, kubeproxy, and for these rules we'll be having Grafana dashboard by default. Go to dashboard, and here you can see API server kubelet. Just choose anyone, you will see the graph of them. Like these all are the, you can see the time series graph of the kubelet. You can switch back to Prometheus and include the instance which you want to see. You can see that as well. Now if you want to check the pods, let's search for pods. Yeah, now you can see this is the ArgoCD. Inside the ArgoCD namespace, this is the ArgoCD pod. If you want to see EGSOP, let's say okay, EGSOP is deployed in EGSOP namespace, and if you want to see this pod, you can see in the pods all this, like CPU usage, CPU throttling, everything, memory usage, everything is there. So you don't have to create dashboards. So that's the reason I told you to install Kube-prometheus stack. It's already built for Kubernetes. So you'll get everything, like all the default manifest from the Helm chat itself. All right, so now we'll do the alerting. If anything goes wrong or any severity, like warning or mm, something will get, then that will be firing to a Slack, so that whoever is looking at it, they will solve that. All right, let's go back to our GitHub repository. Yeah, alerting to Slack. Create a new workspace in Slack. So to create a new workspace, you have to first install the Slack and log in, and then create a new workspace. Let me open Slack, which I already have installed. Yeah, so this is the workspace which I have. You can create a new workspace. I'll just create a new workspace. Enter your email. You will be getting one code. Here itself we could open the Gmail. So till now we have ArgoCD deployed. We have our application. It's still up and running. We have Alertmanager, Prometheus, then Grafana. It's taking too much time. Slack part is taking a bit of time. Yeah, alright. Get started for free. DevOps doc. So now I have two different workspace. This is the previous one and this is the new one. Okay. So now here, let it be loaded. Yeah, okay. Then go to our GitHub repository, create a new workspace in Slack, create a new channel. Okay, we'll create a new channel. Let's say our channel name is alerts. I'll skip for now. You can add peoples, whomever you want to add them. Yeah, the channel I have added alerts. Then we have to create one webhook so that our alert manager will post the alert by using the webhook. So to create the webhook, you have to go to api.slack.com. Go to api.slack. If you Google it, you will find it out how to create a webhook or how Slack works. So this is the previously I had added. Just create a new app. Agree. Create a new app from scratch and give your app name Alert Manager. You can give any name. Select your workspace. I'll choose this one. Then create. Now go to incoming webhook. Active. And add a new webhook. Choose where you want in which channel. I'll just choose this one. Then allow. Alright. So this is your webhook URL. Just copy that and save it somewhere. I'll just open Notepad and save it. Yeah, just save it somewhere. Yeah, you can see when I had added the webhook for this channel. You can see added an integration to this channel, Alert Manager. The application name is Alert Manager. Okay. Now, as we have already added the this thing, now we'll go to now we'll copy the webhook which we already have copied. Go to here, then yeah, this thing is done. Incoming webhook. Now we'll modify the Helm values. So this is the Alert Manager configuration. So one more thing I'll just explain you. So you can create one different Prometheus rule. Let's say your application is exposing metrics in in some API endpoints. So you can take that and create a Prometheus rule. You can just Google it how to create a Prometheus rule, and based on that rule you have to match it. Like in the matchers you have to match it. So for now I don't like this application don't have any metrics exposed, or if it is I don't know, because this is the application from someone else. But to explain you, what I'll do is I will, where is my Prometheus? Yeah, I'll do is I will create the alert based on severity. So whoever severity is critical, it will fire an alert. Okay. The alert name you can do matchers as alert name, like watchdog, but I'll do the matchers as severity. So if the severity is going on, if the severity is going to critical, I mean if it is equal to critical, then only the alert will fire to Slack. Alert manager. Yeah, alert manager, then go to configuration. This is the configuration, and these are the matchers. I'll go to route section and group by namespace. Group by namespace. Group interval is 5 minutes. That's fine. And the receiver is Slack notification. Whatever receiver name you will give here, make sure in routes you will give the same receiver. You can give any name here, but this both should match. Alright, and here the this receiver you have to configure first, and this receiver will go here. That means you can choose any name here, but whatever name you will choose here, that should that you should provide here, because this is the receiver we are creating and this is the route we are providing. So that once the receiver is created, then we are just simply saying, okay, if this thing happens, like if the severity is critical, then the alert route to Slack notification. And what is the Slack notification? The Slack notification is this webhook and this channel, so that in this webhook it will send to this channel. And send resolve, you can make it true or false, so that when it will it will resolve, you will get an alert, so that the severity which was critical, that was resolved. All right, so what I'll do is I'll just copy the receiver, and this thing, like whatever I'm doing it here, I have just provided the documentation. Once again, I'm not doing this all in my mind. I am just reading the documentation and doing the things. This is the documentation, you can read that. If you go to Slack, you will find the Slack rule here. One second, where it is. Yeah, Slack config, you can see. And this is all if API URL and all, that is what I am doing there. You can just read like which things defines what. You can just read and do that if you want to know extra or know more. Okay, yeah. So receiver, I'll configure the receiver. I'll name that as Slack notification. Then copy the Slack config. You can see the Slack config here, which the document I have provided. This is the Slack config. The channel, the API URL, everything is there. Make sure the identations are proper. Oh, here there is an extra space. Cool. Now change the API URL. I will copy the URL from here and add it. Yeah. And then change the receiver name. Change the routes. And the alert name, you can do alert name matches alert name is equal to watchdog, like how I explained. See, alert name you can give this, you can give this, you can give this as well. But what I'll do is I'll do it severity critical, because we have multiple things, so that we can see the alert, like in a shorter time we'll see the alert. We can do try with these as well, like alert name and all. This is kind of a labeling, nothing else. Even you can do multiple, like it's taking as a list. No, you can take multiple, you can give multiple. Severity is equal to critical. Yeah, let's give a space. Alright, save it and upgrade the Helm chart. Let's wait. We'll receive some firing here. Alright, there is no severity. Yeah, there is one severity. Let's check whether we received any firing. Just wait for some time. Yeah, you can see we got some firing. You can see this channel, this is the one we are getting some firing from Alertmanager. Alright, and it will once that will resolve, it will give one another firing as the issue was resolved. Once it is resolved, because we enabled that send resolve to true. Alright, so this way the alerting part is done. Now we will move to the logging part. So these all are things are done. Now we'll move to the logging part. So for logging, we'll use Elasticsearch for the log store, and Filebeat for shipping of the log. We can use Logstash, but Logstash is a bit heavy. Filebeat is a lightweight log shipper. That's the reason I'm using Filebeat. And for visualization, I'm using Kibana. Let's go to install one by one. So in this tutorial, I'll be installing uh, Elasticsearch, Filebeat, and Kibana individually. If you want, you can use ECK operator. That will be a bit easier. And if you want me to make a video on ECK operator, I'll do that as well. But for this tutorial, I'll be installing like everything individually, one by one. And one more thing, you are wondering, like in the initial of the video, we installed load balancer and EBS-CSI driver. So load balancer to that we are using, but EBS driver we haven't used that yet, right? So we'll be using EBS driver for Elasticsearch, because for storing of the log we'll need some storage, right? So to store that, we'll be creating one persistent volume. So the persistent volume that will dynamically create one EBS. So for that reason, I installed EBS-CSI driver, so that when we request one claim, it will automatically provision one EBS volume on our cloud, and the Elasticsearch will store the logs over there. That's the reason we installed EBS-CSI driver. Alright, Let's go and install this one. Anyway, you can go to Elasticsearch here. Like you can go to Artifact Hub and search Elasticsearch and install from here. I'll copy it from here itself. So before that, I'll just create one namespace for the logging part. Add the repository. To add the repository, this is not required. I'll just remove this one, this hyphen and logging. To install it, we need the namespace, because install is namespace specific. Let's check the pods. See, it created three nodes. And to understand Elasticsearch, we have the documentation. You can read from there. So yeah, why it is on pending stage? Because we don't have the storage class. So if you remember, we have the ingress class. So our application, if any request comes in, the controller knows which ingress to choose. I mean which class to choose, and based on the ingress class setting, it will choose the load balancer. Similarly, we have to create one in storage class. In the storage class, we will provide the provisioner as EBS. Then only, and we will make it as default. Then only when we will install Elasticsearch, and inside this one we have a claim template. I'll show you how we have a claim template. Let's go to Elasticsearch. If I go to default values, I'll just search claim template. See, this is the volume claim template. Once uh, we will install, so this claim template will talk to storage class, and in the storage class we have provided provisioner, and through the provisioner it will make a request to AWS to provision a EBS volume. Alright, so this is the reason it's on pending state. Let's go and create a storage class. I'll just copy the code and do vi. You can uh, do through a command itself, no need to create a file, but I'll create a file and execute the things. So this is the only file which I am doing kubectl apply. I could have done this through the command itself. We'll just redeploy this one, and one more thing is, once it is done, we'll just redeploy this one. Let's grab the values file, open the Elasticsearch file. So basically Elasticsearch that has cluster, like in that cluster there is data node, master node, ingest. So this is the cluster of Elasticsearch. I'm not talking about Kubernetes. So the replicas are three. So that means one will be the master and another one will be the data and all, right? So we don't want those many, because our, it's a lightweight application only, so we don't want those many. I'll make it one, and the minimum master node, you can see there are multiple master node you can configure. So that is for like production level cluster. I'll just make it one, so I don't need those many, otherwise those many master nodes or those many replicas. If you specify that, then it will create 3 volumes. So that's the reason I'm reducing it to 1. And let's see what else are there. Yeah, and this cluster health check parameters make it yellow, like it would be green. So the reason is, so once there will be one replica, so all the master data, everything will be one replica. So for this one, the cluster will never reach to the green stage. So it will, every time it will show that readiness probe error. All right, so to get rid of that, we will use this wait for status yellow. This is the health check parameter. Okay, so I'll show you like what is the problem. I'll show you, then we'll define that. Okay, now upgrade. Check the pods. Something is happening. Let's check what is the error. Let me describe it. Let me describe the stateful set itself. Let me do one thing. I'll just uninstall it and install it again. Let me list it first. Then helm uninstall. Then install it back. And mention the file over here. Let me check the storage class. Yes, this is the default storage class. Still pending. Let me describe the pod. There is no events. What is the issue? Okay, let me check the PV. The PV is added. Okay, why it is creating 3 PVC? Alright, let me delete the PVCs. Yeah, because it's running as stateful set, so PVC will not delete. We have to delete it manually. Yeah. showing as pending states. Now check the PB. The application. I'm sure I'm missing something. I can't see any issue over here in this Helm chart. And the storage class is also fine for me. And the PVC is on pending state. Maybe there is an issue in installing the CSI driver. Let's check if it is running. It was running in Kube system namespace. Yeah, the EBS-CSI controller node all are running. Okay, let me describe it. Yeah, the events are expired, so the events is not there. That's fine. Yeah, everything fine here as well. Okay, let me go to the documentation and check again. EBS-CSI driver install. We were following this documentation. We'll go from the top itself. Create IAM role and we edit with EKS-CTL. Let me check the policy if attached, and there is no secrets. If we maybe the controller is not talking to AWS, so that's why it's not getting the secret. But yeah, let's do the describe and check whether the policy is attached or not. Namespace all is there. Let me just get it. Okay, get SA. Auto mount service account token. Okay, it's auto mount already enabled, then it should mount that. KMS key we did ignored, and we installed through Helm chart. Yeah, the installation. Okay, I don't think we did install. I mean we did configure this annotation. We attached the policy, but the role ARN we haven't specified. And the secret. Okay, let me go and check. Yeah, there is no secret access key and secret key and access key. So that's the reason, guys. In the environment itself, we haven't provided the role. In the controller service account section, in the annotation, there is no role. Let me just grab it. Yeah, there is no role specified. So yeah, that is the issue. Yeah, in the service account itself, we have to mention the role. So I'll just do helm saw values. And EBS-CSI driver. I'll update the GitHub repository. So I know this video is getting longer, but this is worth it. Like, I'm debugging the things in front of you only. EBS driver YAML. Now go to service account. Yes. In the annotation, and ARN. So this is the role name which we had created, and just check the role name here as well to verify whether the role is available in your IAM. Yeah, it's available. So this is the role name you have to provide here, and then save and exit. Now uninstall, like uninstall the previous installation of Helm CSI driver. And install it again. We'll specify the values file. Now let's grep. Okay, I need to get the pod first. Yeah, now you can see we are getting the roles. Now let's get back to our pod in logging. Yeah, so the moment we are we have configured the EBS-CSI driver properly, now you can see, right, it's on running state. So it should create a PV. Okay, get PV. Yeah, you can see this is logging Elasticsearch. If I go to see the EBS, if I go to the volume section, now we should see the volume has been created here. That means our CSI driver is working fine. This 30 CV one. Yeah, 29. Yeah, this is the time. This one only. The volume. Alright. Now Elasticsearch is done. It's running. If you are facing any readiness probe issue, then you can specify this wait for status yellow. If it is running, then fine. But let's describe it and check if you are getting the readiness probe issue or not. You can see already it's giving us the warning unhealthy readiness probe, but it's a older event, so you can ignore this one. If mm, uh, if it is green and your pod is not running but it is not active, then you can specify the wait for status to yellow. Now we'll install the Filebeat. Let's go and install the Filebeat. So Filebeat runs as daemon set. So we have three nodes, three data planes. So that's why we are seeing three replicas. Yeah, Filebeat is running. Now what we'll do is we'll install Kibana. Copy, paste. We already have Elastic repository installed, so it's skipping. Copy the values of Kibana. Wait it to be installed properly. Yeah, done. So we have the Kibana value. Now we'll expose the Kibana for the UI, so we can check the logs from there. So we haven't shipped the logs to Elasticsearch. So the thing is, our Elasticsearch is storing the logs. Filebeat, forget about the operator. Forget about the operator because we are not installing operator. The Filebeat will ship the logs to Elasticsearch, and from the Elasticsearch itself, Kibana will parse the log. Okay, then we'll see the logs in Kibana. So it's kind of a centralized logging system. All right. So this graph is bit incorrect. I'll just correct it. Remove the elastic operator. So the bits will ship the logs to Elasticsearch. The application logs. This is my application. I'll just copy and paste it here. This is my application. Yeah, now this is correct. The Filebeat will ship the log from here to Elasticsearch, and the Elasticsearch, from the Elasticsearch itself, we can see the Kibana. The Kibana will parse the log from there. All right. So now to expose Kibana, let's go to the ingress part of it, enable it. The same procedure what we have been doing. Class name is ALB. path type we can mention prefix, and copy the annotation from here itself. Change the host, logs-kibana. Alright, yeah, everything is correct. Save it and upgrade the Helm chart. Let's check the ingress resource. Yeah, so ingress is also available. Let's go to the load balancer and refresh. Yeah, here you can see logs-kibana. Now just go to route 53 and add the record. And copy the load balancer DNS name. So just to switch it to CNAME, create the record. Wait some time. Yeah, now go to logs Kibana. Yeah, we can access Kibana UI. The username is Elastic and the password, you just retrieve the password using this command, which will you will able to see while installing or upgrading a Kibana. You will see this command as a information. Now copy. Basically we are retrieving from the secret, and then login. So here if you go to logs and stream, so these are the stream for all the containers, all the contents. And how you know that these are the stream from all the containers? So it's inside the Filebeat. Let's go and check the, okay, we haven't gathered the values file from the Filebeat. Let's gather the values file first. And so values, then just mention Filebeat. View the Filebeat, and here just go to config Yeah, this Filebeat config. So here what it says, so whatever inside the var log containers, so fetch every log from this path. So this path is basically whenever, like when we are running a pod, so that pod is running in a node, right? And this path is referring to that node's path in which the pod is running. Okay, so our application name is EasySoft. So the what we'll say is, instead of fetching all the logs from the container, just fetch only the log file starting from EasySoft. Alright, EasySoft, then whatever is like next, it will take, like we'll provide that in a wildcard. So now we'll save it and upgrade. We can give the wildcard here as well. Let me cross verify. Input container EasySoft. Yeah, you can add a wildcard here as well, because if it is not starting from EasySoft, then what, like we don't know the naming convention, we can SSH into that machine and we can check the log file. But for now what we will do is, like if a log file containing the word EasySoft, then fetch the log, only that log. If you want all the logs from the container folder, then just put a single wildcard. It will take every log from this path, from the node. Alright, save it and upgrade. My Filebeat. And the file name is Filebeat. Yeah, done. Now just go and check. You will only see the logs from the EasySoft, from the EasySoft application, I mean to say. Yeah, these are all are the logs from our application. So basically, when like the purpose of doing this, when the developer or the QA engineer wants to check the logs and your application is deployed inside a EKS cluster, so you can't, like if you as a DevOps engineer, if you want to see the logs, you can just do kubectl logs, right? But how will they know how their application is performing? So basically here in this way you can expose and provide only the domain, so they can go and they can just go to log stream and they can check all the logs. Whatever your pods are generating, they will just see the logs from here itself. And you can see the alert, like we are getting the alerts and all, and we are getting the resolved as well, like the resolved alert as well, because we set there send resolve to true. So yeah, with that being said, the tutorial has completed. We have ArgoCD deployed, we have our application, and we have exposed Alertmanager, Prometheus, Grafana, then we configured Slack, then we have Elastic for logging, centralized logging. So yeah, with that being said, the tutorial has completed. You can do webhook for GitHub, like git SCM polling. GitHub webhook you can configure to your Git repository. That I won't show you. You just do it. If you are not able to do so, then let me know. I'll add that as well. But that is a task for you, and try to complete the whole project. I have debug all the things, whatever problem I was facing. So whatever things I faced, I just debugged in front of you only. So it will be better to know, and you will find a way how you can manage the things, like how to reach the error level, how to read the error. I know the video is too long, but I think it has worth. So please let me know guys if you like the video. Suggest me if you like the similar kind of content. I'll do such more project. Please do subscribe and like the video and try to complete the whole project. And if you do so, it will motivate me to create such content. And tag me in LinkedIn if you have already done the project. Tag me in LinkedIn and share the video if you really liked it. So finally, I think you able to understood what is going on here. Like first time it might be bit overwhelming for you. For the beginners I'm saying. For the experienced guy, you know all the things already, but I have explained everything in details. I hope it helps. Okay. So for today, that's it. Thanks for staying till the end. Thanks for watching. Bye bye.